A very good morning, and today's topic is photovoltaic cell. And this photovoltaic cell, it is also called as a solar cell. Means the photovoltaic cell, we can also call it as a solar cell. And in our first module, we briefly discussed about this photovoltaic cell. Okay, so this photovoltaic cell, I told it is an device which converts a solar energy into electric energy. It is directly convert a solar energy, means solar radiation, into an electric energy. And here we don't need any mechanical devices like turbines, generators. Okay, we don't need such kind of devices. So with a simple a panel, and that panel with an no movable parts, means that panel consists of an no movable parts, a simple panel which converts direct solar radiations which are falling on that solar radiations, and it converts into an electric energy. And here we don't need any high temperature. A normal temperature, okay, is enough to convert a radiation into electric energy. Then what is meant by this solar cell? So what is this solar cell? What this solar cell, we can call it as a solar cell. It's a solid state device. It is a solid state device that converts incident a solar energy. Okay, that converts incident solar energy directly into an electric energy. Okay, see, so these are the solar panels. Here it's the sun. Okay, so from this solar radiations directly from the sun to they are fall on the solar panels, and this solar panel is a solid state device. Okay, it is a solid state device that converts directly that solar energy falling on that into an electric energy, and that electric energy we can use for our any household purpose, or we can store it in electric grid, and we can supply for industry purpose, or else we can go for any further applications, useful applications. So this energy conversion device, which are used to convert sunlight into electric energy by the use of photovoltaic effect. It is by the use of photovoltaic effect, and are called a solar cells. Means with the help of photovoltaic effect, it converts that solar radiation into electric energy, and the device what we can call it as a solar cell. A converter cell is called solar cell. Means a single converter cell, a single cell. There's a one single cell. Okay, here one single cell, or a more generally it is called photovoltaic cell. This entire thing we can call it as a photovoltaic cell, and a combination of such a cells, okay, and designed to increase a electric power output, and it is called solar module or solar array. We can call it as a solar array or a solar module, just to increase the power. Okay, if you want to more power, you can go with a more solar cell, and such a combination of solar cells we can call it as a solar module or a solar array. Okay, and this photovoltaic cells are generally, okay, in general, okay, so what it made by? Here I told in the solar cells there is no movable parts. Okay, only simply a solid state of devices. Okay, then how it constructed? So what it contains? Okay, so generally this device is contain a semiconductor. Okay, we use a semiconductor which are made by this PV cell or a solar cell, and these cells, okay, and these semiconductors, okay, when the light is fall on that, they will generate the electric energy. That we will discuss in the later part of this topic. And these solar cells are they are not heat engines. They are not heat engines, even though they will generate the electric energy. Therefore do not need operating high temperature. With a nominal temperature we can operate this, and they are adapted to a weak energy flux. Means when the cloudy days, okay, in the evening time or in the morning time also, these solar cells will operate, and they are operating at a room temperature, and they will generate the electricity, and their theoretical efficiency of these cells nearly 25%. up to 25 to 30%. The efficiency of these solar cells is up to 25 to 30%. When compared to other electric energy generation devices, these devices having an lower efficiency. And the best application of this photovoltaic cells, we go with so many applications that we will discuss in the last bit of this photovoltaic concept. So these cells, the efficiency of the power development of these cells is, I told, only 25 to 30%, and with a free space it can generate 1.353 kilowatt per meter square. So per meter square in a free space it can be generate 1.35 kilowatt per meter square. So that much of energy it can capable to generate. Okay, and these cells come to the construction. Okay, so this is what in the slide you can able to see the a construction. So construction means which are the parts which consists of this PV cells, means which are the parts, okay, or component it consists of. That is what the a construction of PV cells. This PV cells mainly consists of a solar cell array, a loader leveler, a storage system, and tracking systems. These are the main a component it consists. Okay, and come to the this is solar cell array. So this is what the a solar cell array. Okay, and it consists of some of the important parts like first thing, it consists of an, okay, so anti-reflecting coating. Okay, so this is a glass. First thing is glass. Okay, and this glass, inside that, this is a glass and this is sun where we get the energy, and these are the radiations which includes beam radiation as well as the direct radiations. And this metallic conducting strips, it consists of metallic conducting strips as well as p type, n type, okay, substrate base, and depletion layer. Okay, so these are the some important parts which consists of. See, this is the first, it is made with a glass, okay, a glass lens. It is a transparent glass lens, and beneath that there is an anti-reflecting coating. So it is coated with an anti-reflecting coating, and beneath that there are two materials. There are two materials which are called p-type material and n-type material. Okay, and last one is a substrate base. So this is called as a substrate base, and these things we connected with an a positive type and negative type electric circuit. Okay, and directly what happens here. So the semiconductor materials, first we should know what is meant by a semiconductor. First thing you should know, so what is this semiconductors? So semiconductors, we generally know that they are the materials. The means these PV cells are generally made with the semiconductors, and these semiconductors are, they are basically a materials. They are materials. Okay, and these materials have no free electrons when they are in the normal state. When they are in the normal state, okay, and when there is no free electrons. These semiconductors are when there is no free electrons, and they won't generate the electricity. These semiconductors in the normal state, okay, just in the normal state, they won't conduct electricity, and also they won't have any free electrons or free electron charges, or there is no atoms, free atoms. Okay, and when they are added with some other materials, when they are added with some materials, they will become they will change their characteristics. They will change the characteristics when they are in the alone material. Okay, when they are in the alone or single material, they won't have any free electrons. Okay, they won't conduct any electricity. But when they are added with some other element, they will become a semiconductors. Okay, initially, okay, they won't conduct. Initially, they won't conduct, and they are not conducting materials. But when they are added with some other materials like cadmium, okay, so these are some materials. If they are added with uh, some other materials, arsenic, okay, boron. If you added with these materials for that non-conducting materials, they will start conducting, they will start producing the free electrons like n type, p type. Okay, so this is what the semiconductor concept means. Semiconductor means before they become a semiconductor, they are only non-conducting materials in the normal temperature. Okay, they won't conduct any electricity, they won't have any free electrons. But if you added with, if that material is added with some other materials like arsenic, boron, like this, they will become semiconductor. The semiconductor means they will have some free electrons, okay, they have some vacant electrons, and they will start generating a positive type and negative type electrons, okay, and they will start conducting the electricity. So this is what we call it as a semiconductor. Is it clear? And here some of these materials are, okay, silicon, a cadmium, okay, so these are the commonly used, and mostly we are using a silicon material. So silicon is used as a semiconductor. Is it clear? We are using silicon as a semiconductor material, and these silicon, okay, and they are added with, and here this silicon, okay, basically silicon is a material, okay, it's an intrinsic semiconductor material, silicon, okay. Intrinsic means it is internal properties, internal properties. And this actually silicon have an 4 valence electrons. It is an completely filled with a 4 valence electrons. Clear? And they are tied up with a chemical bond, and there is no free electrons at absolutely 0, means there is no free electrons. And this a piece of this silicon is doped on the side of, means if you added with, okay, some other materials like arsenic. If you add this silicon added with a phosphorus or arsenic, if you add the silicon with a phosphorus or arsenic, then it is become a semiconductor, and with an excess of 1 electron. It is an excess of 1 electron, means 4 to 5 electrons. Now that silicon will become a 5 electrons. It have an 5 electron, 1 electron is excess, then it is become a n type semiconductor. See here. So here this is an n type semiconductor. This semiconductor means it's a silicon. This silicon is added with a phosphorus or arsenic. If you add with phosphorus or arsenic, then it is become a 5 electrons, means 1 electron is excess electron. So 4, actually the silicon have only 4 electrons, there is no free electrons. But if you add with this phosphorus, it will add 1 more electron, and it is become that the entire alloy is become 5 electrons, 1 electron is excess. Now it is become an n type silicon. Clear? So, and this excess electrons will practically free to move on the semiconductor lattice, means on the lattice of this semiconductor, this 1 electron means it have a 5 electron, so 1 is an excess electron that will start freely moving on that lattice of n type electrons. Okay. On the other hand, there is a p type electron, and the p type electron, the same silicon, okay, actually it is have a 4 electrons. When you add with boron, if you add a different material like boron, then it is become a 1 valence of electron material, means 1 deficiency. So it will start 1 deficiency electron, and it is become only 3 electrons. Mean it will create a 1 deficiency in the electron. Now it is become a 1 deficiency. So instead of 4, it is become a 3 electrons. So 1 deficiency will created by adding boron. Clear? Now it is become a p type electron. So here we are adding phosphorus or arsenic, here we are adding boron. So for the same silicon, if you add these 2 different type of materials, it will become a n type and p type. So n type means it's a negative type, means it's a 1 excess electron. P type means there is a deficiency of electron, so that it will become a p type of electrons. Clear? And this deficiency is expressed in terms of excess of holes and free to move on the lattice. Excess of holes means it will create the hole. Okay, deficiency means it creates the hole. So here actually okay, so for free electrons there are 5 free electrons, but here only 3 electrons. Okay, so one deficiency will created and here one extra electrons will generated. So that is what n type and p type. Okay, so by using this concept n type and p type, this is what we can call it as a pn junction. Means here it will create the pn junction. By using this pn junction we are going to generate the electricity. Okay, and here so some of the combinations. Okay, some of the characteristics or some of the combinations what we made on this PV cells before going to actual working of PV cells. Okay, so next we will discuss the working of PV cells, how it working. So before that we discussed some of the characteristics of solar cells. So what characteristics it have? Okay, so we know that the working of this PV cells, it just a junction, PV junction. So that is what dissimilar materials, that is what p type and n type material semiconductor, and it creates the voltage and the energy from the sunlight. Okay, knocks out on the electrons and creates electrons and in the hole and in the junction that connecting both side of an external circuit causes the current to flow. So this is a simple concept. Okay, so based on this simple concept, okay, so some of the characteristics of this PV cells it have. The first thing is a this is what the theory of IV characterization, the theory of IV characterization. And next the short circuit current and open circuit voltage, then maximum power, then filler factor, then efficiency. Okay, so these are the some characteristics which have this PV cells. Okay, so first if you know this theory of IV characterization, means a PV cells can be modeled. This PV cells can be modeled as a current source in a parallel with the diodes. Okay, and when there is a no light present, if there is no light present, so there is no electric energy is generated. We already know that if there is no light, okay, at least a minimum light is required for generation of free electrons. If there is no light, means it won't generate the current. The PV cells behave like a diode. PV cells behave like a diode. As an intensity of light increases, if the intensity of light increases, the current is generated by PV cells. That is most important thing. Okay, see here. So here, if there is no radiations, no power generation. If a small amount of radiations, then it will start generating the current. It will generate the current in the PV cells. In an ideal cell, the total current high, current high which is generated, the total current high, okay, which is generated, it is by photovoltaic effect, by means it is given by I is equal to I L minus I D. Okay, it is given by a equation called I D and I L. So I, the total current generated, I is equal to a I L, means a current generated by photovoltaic effect, okay, minus ID means diode current. A minus of ID means diode current. The total current generated is equal to IL. IL is the current generated by photovoltaic effect minus ID means a diode current. That gives the total current generated in that photovoltaic device or PV cells, where this I it is also ID, okay, this ID is also given by I e raised to q v divided by kt divided by a kt minus 1. So this ID we can replaced by, okay, e raised to q v divided by kt minus 1. Okay, so this into I naught, where this I naught, it is a saturation current of the diode, which is the saturation temperature of the diode, and q is the elementary charges. It is the elementary charges, and it is equal to 1.6 10 raised to minus 9 coulombs, and k is the constant value. It is the k is the a constant value, 1.38 10 raised to minus 23 joules per Kelvin, and T is the cell temperature in Kelvin. Okay, either you can take it as a Kelvin or degree centigrade, and V is the measured a cell voltage, okay, and either produced by produced or applied. Either this voltage is produced or the voltage is applied. Okay, and finally this equation we can written as I is equal to IL minus I naught into exponential that q is replaced q, okay, v is there, no, that v is replaced by v plus I into rs divided by, okay, kt into n and minus 1, okay, and whole into minus v plus I into rs divided by rsh, okay, and this rs and rsh represents the series and shunt resistance. They are the series and shunt resistance of that PV cell. Okay, so this is a first equation, and it is given by for the theory of IV characterization, first characteristics. Okay, next is a short circuit current. Second characteristics is a short circuit current, that is a short circuit current ISC corresponds to the short circuit conditions when the impedance is low, and it is calculated when the voltage is equal to 0, and it is given by I is equal to ISC where V is 0. Clear? When ISC is equal to I max where I is equal to IL. Okay, so that is what the it's a equivalent ratio. And the next characteristics is a open circuit voltage. The open circuit voltage V, okay, open circuit voltage, so capital V OC, okay, it is given by a V when there is no current passing through the cell. So when there is no current passing through the cell, then V is equal to VOC. The VOC is also the maximum voltage difference across the cell for forward bias. Okay, so VOC maximum, V maximum in the forward bias quadrant. And the maximum power, so where when the maximum power, so the power produced by cell in watt, it can be easily calculated along the VI swap. That is what we know, just only know the equation, and that equation we can written as P is equal to I into V at the ISC and VOC point. We already know that VOC means it is the open circuit voltage, and ISC means a short circuit current. The power will be 0, and it is maximum value power will be occur when the when at the 2. The voltage and the current at this maximum power point are denoted by VMP and IMP respectively. IMP and VMP, we get the maximum power output. And the filler factor, so it is a filler factor, means it is called as FF factor. It is very essential to measure of a quantity of solar cell. Okay, it will measure the quality of the solar cell, quality of the solar cell. It is calculated by comparing the maximum power to the theoretical power, means by comparing this maximum power and the theoretical power, that would be output of the both the open circuit voltage and the short circuit voltage. And this FF can also be interpreted graphically as a ratio of rectangular area. Okay, and this ff is given by, okay, so this ff, the equation is given by, which is equal to P max divided by PT, filler factor. Ff means filler factor. So P max divided by PT, where P max is equal to IMP VMP, means current and voltage both are maximum, and PT means the ISC and VOC. Okay, so the larger filler factor is desirable and correspond to IV swap, and that is more square like, and this filler factor always ranges from 0.052, okay, 0.052 to 0.82. So that is the filler fact value, 0.5 to 0.82. And the last one is efficiency. We already know that all the devices have their efficiency. Efficiency means it is an output to the input. So here the output is compared to the solar power, and the input is what the radiations is onto the PV cell. Okay, so the electric power is the output, and the solar power is the input. What the electric power, electric energy we are getting from the PV cell is the output, and what the solar radiation is falling onto the PV cell is the input. That decides the efficiency of the device, and this efficiency of the device, it is given by N. So there is mu. So mu is equal to P output, power output divided by power input. Okay, and we already know that this efficiency is up to 25 to 30%, maximum of 25 to 30%. So these are the some characteristics of this solar energy. Okay, and these cells are generally is with a series and a, so these are the two combinations. One is a series combinations and a parallel combinations of PV cells, and these two are current and voltage. Okay, I and V graph. If you draw the I and V graph, we can achieve. So here the voltage and the current, and this is another combination is also possible, series and parallel combinations both. So we can go with the series as well as parallel, just to increase the power output. In the series parallel combination, the cells magnitude of the both voltage and current increases, and thereby solar panels are made to use the series and parallel combinations to increase the power output. Yes, so this is a very important concept of this PV cell. Okay, so working of PV cells, that is most important, how this PV cells are working. So I told this PV cells is with directly converts that solar radiations, whatever the solar radiations falling on that, it will convert that solar radiations into electric energy. Here this the working of this PV cells, it is directly with a semiconductor junctions. Okay, here there is a junction which formed by two P type as well as N type and P type. So N type is because of excess electron. A P type means it's an deficiency in the electrons, that causes the two positive and negative type of junction, and between these two there is an interface between P and N type. There is a junction, it forms the junction, and the junction is called a PV junction. And in the PV junction, what happens when the solar energy or when the light is fall, okay, from the sun to directly enter into the atmospheric and directly reaches to the solar panel, that is what the cover, and through the cover it will reaches the two semiconductors. One is an N type, and next to N type there is a P type. Okay, so one it fall onto the light is fall onto the these two semiconductors, and because of light energy, because of the light means it have the energy. Okay, the light have energy called heat energy, and it will rise the temperature, and that rise in the temperature will start the means it will these energy is gained by n type as well as p type semiconductors, and by gaining this energy, and it will start moving the free electrons here, and here the holes will start moving onto the p type, and excess electrons will start moving onto the n type. So it will start freely moving just to because of the light energy. The light energy will give the necessary power or necessary heat or necessary temperature to move the free electrons, or to move the free holes on the p type, and to move the free electrons in the n type. Okay, when there is no light, there is no heat energy, and there is no moment in the n type, or there is no moment in the p type. Is it clear? So no moment in the p type and no moment in the n type when there is no light. When there is a light, that light will start initiate or start, it will give whatever necessary input for the n type and p type, so that they will absorb, they will gain the energy, and they will start moving the electrons and moving the deficiency hole in the p type. Okay, so this moment, okay, free moment, positive and negative, okay, the moment of this positive and negative, that will creates the necessary electricity. Okay, that will connect. So this is connect, this p type connect with the positive, and n type connect with the negative, and these two will forms the necessary electric energy. Okay, that will forms the voltage. Okay, that voltage will generates the necessary current. Clear? So this is the working concept behind this PV cell. So PV cell, directly there is no light means there is no power. Okay, when there is a light, that light will initiate the, that will directly fall onto the semiconductors, and it will start move the free electrons and move the valence electrons, and they will connect to the positive and negative, and they will charge that positive and negative, and directly they will forms the electric energy. Bonded 4 electrons. If you give another element for that, okay, if you add another element, it will creates the a free electron and excess electron and deficiency. By adding arsenic and by adding boron, we can create a p type and n type, a different type. See, here the hole is created. In the previous, the excess electron is created. Here the hole is created. This is what p type, and the previous one is n type. There are two types, and if you join these two, okay, here excess electron is there, and here a free electron is there, hole is there, and here excess electron. This is what n type, and this is what p type, and this is a depletion region. That is what interaction, p n junction. It is also called as p n junction. Here positive and here negative. It creates, negative means one valence electron, deficiency of electron, positive means one excess electron. Okay, when the light is fall on, this is what the solar radiations. Okay, when the light is fall on, and the electron holes pair will generated, because by observing that light, it will generate the excess amount of hole, and by observing this, it will create the excess amount of positive electrons. They are free to move within the that material, within the material they are free to move. See, like this, they are free to move, and the potential differences, there is a potential differences, and here it will supply we need, for generation of current, we need a positive and negative, and it will supply a necessary a positive, and it will supply negative. Okay, that is the concept, and the same concept which are heavily doped and lightly doped. Okay, as when the light is fall on, see, so like this, parallel and series, this is what a cover and anti-reflection layer, and these are the semiconductors, positive and negative semiconductors. Like this, series and parallelly we connected. So come to the advantages of this solar energy. Okay, so there are so many advantages, and this first advantage is the direct room temperature. We don't need any higher temperature, the direct room temperature, so that will converts a light into electric energy. That is the first advantage, the direct room temperature, 30 to 40 degree or within the 50 degree, it is capable to generate the electric energy. We don't need any higher energy, first thing. Second thing, absence of moving parts. Here you just see in this figure, there is no moving parts. Simply without any moving parts, simply it will generate the electric energy. But in some cases, turbines, IC engines, okay, we need a moving, continuous moving parts. If there is a moving parts, there is a maintenance, okay, there is a wear of tear, there is a loss of material. But here there is no moving parts, the maintenance is very less, and also wear and tear of the materials is also very less. That is another advantage. And ability to function unattainable a longer period. Okay, it can continuously operate with a longer period. That is another advantage. And modular nature, in which desirable current, the voltage, power level can be achieved with an integration. Means we can easily attain a higher temperature, higher voltage by continuous usage of this electric solar radiations, and continuously we can generate. And maintenance cost is very less. The maintenance cost of this is very less because of there is no moving parts. Only we have to clean the solar panels, just to if any dust is if there is any dust placed on the cover, we just clean that dust, so that we just allow that solar radiations easily passes through the cover to reaches the semiconductors. And they do not create a pollution. Of course, there is no combustion. Here it's a free, it is a eco-friendly. Okay, here it is called as a green power generation, means there is no combustion, so there is no pollution. So pollution is absolutely zero. And they have a longer effective life, means the part life is very long when compared to the other type of power generations. Here the parts, whatever the parts we are using, they have a longer life. And they are highly reliable, means we can easily reliable, because there is no maintenance cost and life is long, means we can easily reliable, we can easily trust on the parts. And they consumes no fuel, so only they consume solar energy, and they are regenerating continuously, and they are inexhaustible. They are renewable source of energy. They have rapid source output, means easily we can generate. Means one side the solar radiations is fall, and another side we can easily get the electric energy. The conversion is very high, radiations to electric energy is very high. And they are easy to fabricate. Of course, they are easily fabricate. Wherever we needed, we just placed on that solar panels, because solar panels are easily manufactured, and they are placed. If you want the roof of the house, we can easily place. If you want if you use a solar trees, just like a branches, it consists of solar different panels, and we can generate the energy wherever we want. We can easily install, and we can get the electric energy. They have high power to the weight ratio, means the weight is very less and they get the high power. But when compared to the turbines and IC engine, the weight is very high, and the power is also of course high, but weight ratio, weight to power is very low in case of those things. But in case of this solar panel, the weight is very less, and we generate the high power. That is another advantage. These can be used with or without a solar tracking. If you want, we can use a solar tracking. If you don't want, we can don't use any solar tracking, and we can generate the energy. It is also another advantage. So these are the some advantages. And the disadvantages is a high initial cost. Initially we need some initial cost for that manufacturing of solar panels. That is one thing. And moreover, the sun is not continuous, the variation in the radiation available, it is another drawback. Okay, and the effort has been made to this worldwide to reduce the cost through the various technology. Nowadays the research has been going on and to reduce the initial cost and also the conversion to increase the efficiency. The efficiency means output to the input. That efficiency is also very important. This is a non-conventional one. Why? Because the efficiency is very less when compared to the conventional source of energies. And next, how this solar cells are installed on the solar plant, means how we are going to install. So first we construct the solar panels. This is what the solar panels, okay, and this solar panels is constructed and it is placed on the roof of the house, okay, and then the means where the solar energy is directly fall onto that panels, and it will converts and it is moving into the MPPT, means maximum power point tracker. Then through that it will DC current, the where we use the batteries, okay, that batteries will convert the DC into the ACs, okay, that there is a conversion, and that AC current, alternate current, can use for our household purpose if it is for single or double panel. If you use n number of panels, we can easily use for the industrial applications, means it will generate the more power. And this is the application of photovoltaic cell. So firstly it is used for the power generations, just only I explained the first application, power generation. Second application, solar farms, means solar farms, they are acres of PV cells can provide the utility of cycles, means if you go with the solar farms, means n number of solar panels are used, they will generate the high current, means the power generation is in terms of megawatts to the gigawatts, okay. Then they will generate the huge amount of electric energy. And these solar panels are easily placed in the remote locations where we cannot able to supply the electric energy from the electric grid, okay. From the electric grid we cannot able to supply the electric energy. In that situations, easily we can place the solar panels and we generate the electricity in the remote areas. Then a standalone power, means it can stand alonely, we can generate the power, okay. It won't need any moving parts, okay, it won't need any maintenance, everything. And the power in the space, yes, of course, in the space settles, okay, satellites, they generate the power with the help of this photovoltaic cell only. They are using this photovoltaic cell to operate the satellites. Then building and related needs, means building for house purpose, building purpose, we can use this type of solar panels for requirement of this household appliances. Then military uses, in military for drone, some of the drones are also used, or some of the equipments they are used, means where we cannot able to supply the electric energy, or where we cannot use the batteries or other things, we can use directly the photovoltaic cell and they will supply the whatever necessary energy for operating military uses. Then transportation, of course, solar cars, solar bikes, okay, solar vehicles also they are nowadays, you heard about that. So that is a solar transportations. So these are the some applications of this photovoltaic cell, okay. So with this I am going to wind up our third module.